Okay, thank you, Massimo. I've got my slides and my clicker. I have to say that I am going to be taking a very much more prosaic approach to this than Matt did. But I think I hope I've identified some things that we should think about perhaps and have a bit more of a conversation about. So, which one? It's got it the wrong way around. It's the one without the thing. Right, there we go. So my first thought when Yvonne asked me to speak was a little bit about what do we actually mean by societal impact. And most of the time, when I'm asked about it personally, and I think the broad discussions we were having yesterday, our natural instinct in some ways is to talk about the public engagement, the outreach, the educational impacts, and also, as Matt was identifying, the inspiration, the international collaboration and teamwork and the value of all those things. But there's another aspect to this, and I think it's something that our governments look at, which is what they mean by societal impact is something much closer to economics. And an example of that in Europe is the very carefully observed and policed and measured ESA Just Retour system. So the idea here is that all of our national governments invest in the ESA program, including the science program, and then they look and monitor that that investment comes back fairly to their country through Just Retour. And they look at the science program for this, not just the other aspects of the ESA program. So I think that there's a broader and much more prosaic aspect to societal impact of astronomy and of JWST. And of course, historically, we could point to agriculture. That's how you knew when to plant things, the measurement of time, the importance of navigation. In the modern world, I think it's Wi-Fi, where the technologies that underpin Wi-Fi and that might rapidly be becoming less relevant, but they have their origins in radio astronomy and other aspects of technology. And I'm going to just talk a little bit more about some examples of that to try and get us thinking. I think we need to get better at articulating this when we're looking for investment in the next big missions. These investments and the investment in JWST is a very high-tech investment, which means in the end, it was an investment in people and skills. Matt's already mentioned the huge numbers of people who worked on that mission. All of those people learned things from working on it in engineering or in science. And there are many people who worked on JWST who now don't work on the science program. They've gone on to work on other things in other areas, and they've taken that knowledge and the experience and the things that they've learned to the things that they're doing now. And I think this is really a very broad impact in how you build things, how you do engineering for all sorts of different purposes. And it's important that, you know, we're all inspired by doing astronomy because we're all astronomers, but we need to recognize the engineering that underpins what we do and the impact that that has, because that's part of the impact of our astronomy. So I've got a couple of examples here, and I'm often asked about spin-outs of technology, and I think it's more subtle than technology. So I've called this applications of techniques. There are a couple of examples from the UK ATC because that's what I know about. I think I see these subtle applications in many of the conversations I have with many different people that were involved in building JWST, so they're not unique. But this is about taking what we've learned in astronomy and how we build things to other areas of science. So it's not about a specific technology, much more about a technique. So one of them is retinal densitometry, and I think there's a NASA example of something from JWST in this area as well, because I'm sure I remember reading about it when we were working at the UKTC on this. But retinal densitometry is one of the leading causes of blindness in old age in the West. So it's a very big issue in medical science. And the question is, how do you measure when it starts to happen rather than finding out after people have gone half blind? And what we've done here is we've built something that's now in clinical trials at Cardiff University. So we were not the lead on this. Cardiff University were, and medical sciences at Cardiff University were. But the application of it is it uses a lot of the things we learned on MIRI. Some of it is about how you control down to tiny, tiny low levels scattered light in your optical designs and your optical surfaces. Some of it is it's taking images in multiple wave bands, which is related to how we split up all the multiple wave bands in the MIRI MRS. And it also applies something from ground-based astronomy, which is that if you're asking people who are unwell and they're partly going blind, one of the problems that opticians have is it's very hard to keep your eyes still and looking to the machines and make sensitive measurements. And so what we've applied here is the tracking that comes from adaptive optics in a closed loop. So this is why I'm saying it's about techniques. It's not about a technology. It's about the areas where all of that engineering learning then goes and helps something else entirely, and potentially the scientific, the sort of societal impacts of this sort of thing are huge. Another one is the GHOST mission. This is slightly more directly related in that it takes the design that we used for the MIRI image slicers, and in fact, some of the data from it would look recognizable to you in the way it's arranged on the detector. It's subtly different because it's in Earth observation and the Earth rotates and the UAV is flying over the Earth to make the measurements. So it's a scanning instrument. So in some ways it's completely different. And in other ways, it is an application of that design to something new, and it helps to get, because it's the same as in astronomy, you're building data cubes rather than just individual spectra. So you're getting a much finer spatial resolution in this data in terms of understanding the atmosphere of our Earth. And we all know, I mean, we all know there's problems there. So this is, but I think again, it's mostly about the technique and the designs of the instruments and whether other people instrument. And again, this was earth scientists at the University of Leicester and the University of Edinburgh, and we helped them out with, and I think that this is going on a lot in our community, this multidisciplinary discussions, and it's something to be encouraged, and it's maybe something we need to get better at talking about. And the last one is a data example. And this is quite an old example, except for that it's still going, because there is a global biomass virtual observatory that is being used by Earth scientists, and it has some of its origins in a connection that was made through this little project called Astrotrop. This is really quite old now, but it's gone on in terms of a useful discussion between Earth observation scientists and astronomers about how you handle your data, how you bring databases together. And it left me thinking, you know, what are we learning in JWST in terms of modeling techniques? Because I see the chemical modeling that's been presented today. I mean, it's all new. We're doing something new with our data that's more than just doing new things with our science. And where might that, could others be using that? So I think there's a real possibility here for more of this sort of thing. So having talked about the prosaic, I wanted to come back to not the quite so prosaic, and also because I think maybe not very many people in this room know this, but the German Society for Photography awarded JWST their 2023 prize for science, pulling out, of course, obviously, especially the European and German roles in MIRI and in NIRSPEC. But this is societal impact that now is happening. We've started something. This wasn't anything that was driven from the astronomy community or from NASA or anybody else. They've looked at what's out. They've looked at Klaus's success and come to their own conclusions about it. But it's also interesting what they had to say in the citation for it about how important it is to recognize images and the role that images play in our culture and society. And I thought that was very pertinent to the discussions we've been having over the last few days. And it's also nice that it's being recognized. And so just to finish with another example of societal impact that is just happening, and because I like galaxies and I like standing stones, what I think this is a perfect illustration for me of the societal impact of what we've done with JWST. Thank you.